Hey everyone, I have another video for you today. This one is going to focus more on the technical side since a few of you were actually interested in that, and I promised that I would do that video or do this video in the last video. So here we are. I will warn you, I don't have like a script or anything really prepared for this video, so I don't know how long it's going to be or where we'll end up. So bear with me as we go through this. First thing, I guess, is just I use Visual Studios for development. You probably know that. I use C# and as of recently, I am using the monogame framework, which is kind of where the huge time gap in between videos came from. I was busy as well as switching over to this framework, which means I have to kind of reconstruct some stuff because I didn't like where it was headed in the other solution. But if you don't really know Visual Studios, don't worry too much. This will be kind of high level. So yeah, don't worry if I'm going too fast or if you don't understand something, it won't be a huge deal. I'll run this solution just as is. You'll see the main window here, our main game window. So if you watch the last video, you'll notice a couple differences right off the bat is that there are footprints and there's also some chimney smoke. Just threw those in there since they needed to be done anyway. For that chimney smoke, it's actually not even the chimney smoke that's from the original Golden Sun. It's from the Lost Age because I thought it actually looked a bit better than the one they used originally. But yeah, so this is what the game looks like when I run it as a release build, which kind of in layman's terms is a build that I would demo with or show you guys in videos as kind of like the finished product, if that makes sense. I also have a debug configuration of this, which I can show you if I just change the release to debug and then run it again. You get to see all this other fun, weird stuff. So top left is just some debug information. All these squares and circles are collision data related. I will actually put some more debug information here, and it's a little hard to read, so I'll make it easier to read for you. Just give me one sec. Mouse cursor is flashing like crazy, so it's hard to see this. So I'm basically just configuring a debug class here that I use to just show various things whenever I need them. Sorry if the keyboard is loud, it's a mechanical keyboard. Let's see what this looks like. Okay, so we have some interesting stuff. Let's see. Yeah, it should be good for right now. But yeah, basically, as you kind of walk through the map, all these tiles are configured to do glancing and collision data, which is very similar to how the game actually does it. So you can see these little triangles here that will deflect him on a 45-degree angle if I move up. And then these pots in the front are a circle, so if I hit them square on, they're pretty good at deflecting just off to the side. Whereas if I go to this square here, it's not going to deflect me off to the side. I should point out that I'm using a program called Tiled to do all the map configuration and the collision data stuff is stored in it, and the event data is stored in it and stuff like that. Another thing you'll see here is on the stairs, what will happen is, just like in the actual Golden Sun engine, as I go up those stairs, the Z coordinate on my sprite location is going to change, which will look kind of funny because what happens is this little green circle here is his collision radius. So anytime he hits something with that little circle, it will try to either glance him or it'll stop him because it can't glance him. But as I go up these stairs, you'll see that the circle is now kind of away from where he is. It's actually, I think, 32 pixels up. So right in this spot here, where Isaac is actually standing, there's a gap in between the tiles, but I can't actually go in that gap because if you look down where the circle is, I am hitting those two blocks. So basically the collision data is just reading where that circle is, and wherever that circle is where Isaac is allowed to go and stuff like that. So then as I come down the stairs, the circle comes back to where he is. And that's pretty much the same as what the Golden Sun engine does right now. I basically decided to copy it. I don't know if it's the best structure. It seems to work, and the previous engine that I had, it basically just worked off of lines and stuff like that. So it didn't work very well when it came to things like if you want to move a pillar and then you want to move onto that pillar from a higher level, it becomes difficult to do it the way I had structured it. And I mean, the Golden Sun developers figured all this stuff out, so there's not really any need to recreate the wheel. So yeah, that's kind of how the collision data stuff is managed, or how it performs in the game. I can actually open up the tiled editor and you'll see, so this is the town here in tiled. I got a tile set over here, which I used a tool that I made to just easily and quickly generate all the unique tiles and then place them all in the right spots, so I didn't have to do it manually or anything like that. So if I take off layers, you'll see stuff going away, and all this data actually comes from the editor that Atreus made. So I basically just pulled out all those layers and made them how I needed them. There's actually only 3 layers that come from that editor, but I split it out for layering and stuff like that. So if I show this collision layer here, you can see all those little blocks that are drawn in the game. And if I click on one, you'll see it just has a property that just says height of 16. So whenever he gets to that tile, he won't be able to hit it because the difference between his current height and this tile's height is too large. So assuming he's walking right here, you'll have a height of 0, and when that little green circle hits this tile, it will see that his height is 0 and this height of this tile is 16, so a collision happens. And if it can't glance him, then it will prevent him from moving. Here you saw in the game it actually draws a circle, so what's happening here is there's a couple other properties defined. I just give this circle a radius of 8, and then in code this type 2 corresponds to creating a circle type collision tile. And then if you remember, these ones were triangles, so similar concept. There's just a couple of extra properties that define it. So the orientation is just 1, which means there's one of 4 values, and that just dictates which way the triangle will actually face in the engine and stuff. And then type 3 is just defines it as a triangle tile. So that's pretty much tile data. Oh yeah, I can go into collision indexes here, so I'll just zoom out a bit. So this is collision index layer 1. So if I move over to the top here, you'll see that there's a whole bunch of tiles over here that are for the stairs. And then actually what happens when he gets to the top, it will change his collision index to use a different collision layer. So after he climbs the stairs and that green circle is 32 pixels offset from him, he'll get to the top, and then it will actually use this collision layer, which doesn't help. Anyways, when he gets to the top, it uses this collision layer, so that green circle is sitting in here, and it moves along in this on this collision layer. So there's just a tile in here that tells it that when he hits that tile, set his collision index to 1, which will switch it to this. And we saw that in the game when, if I move up here, as soon as I hit that tile, it switches to that other collision layer. That's basically just what that tile does and how it's managed. The purple or magenta color, when it goes a magenta color, it just means that the sprite or Isaac is intersecting with that tile on one of the collision points that defines a collision, basically. So those little red points on that green circle define where a collision can happen on the circle, which is important because you don't want a collision to happen when he's facing north in this case. You don't want it to happen on the bottom south part of the circle. Mostly because you'll get stuck in a lot of places very easily. So these graveyards use that circle as well, just so that it's easy to get around them when you're running full speed at them and stuff. So that's glancing and collisions and all that fun stuff, and that's how it's stored in the game, and that's how it's done. My mouse is basically not visible. I can go just kind of into what events look like as well. So there's only really a few events that happen on this map, and that's when he does sliding across the ice. Just does an initialization on each of those tiles that puts him in a sliding state. We can actually show that here. Let's just show that. So this will just show the current state of the sprite. So right now he is normal state. And then as I move up to this tile, you'll remember that one of these tiles was the event tile, which is just kind of layered over top of the collision data right now. I don't know if that will change later or if I'll integrate all those tiles together, but for right now they're separate. So when he moves onto that tile, just puts him in a sliding state, which you can see is changing from normal to sliding. And what happens there is whenever he's in a sliding state, it basically just moves him in the direction that he tried to go until either he hits another event tile which stops him, or he hits some collision data that prevents him from going anywhere, which makes it pretty handy because I don't have to do any major tile coding. I basically just put him in a state of sliding, and then everything else just gets taken care of on the collision layer. So I only have to put tiles where he needs to be stop moving and stuff. The ladder and climbing actually works the same way. So he'll, as I push up on the keyboard, his state will change from normal to climbing, and then while he's on this ladder, he's in a climbing state, which basically tells the game what animations to use, and there's a class that actually dictates what how the input from the keyboard is controlled while he's in a climbing state. So you can see as I move around on the keyboard, I'm actually changing his collision points on his collision circle, but he's staying in the same direction so that I can use all of the collision data to just prevent him from going anywhere else in on this ladder. And I've actually pretty much fully implemented the climbing system, so I could change this to so he could climb side to side and up and down diagonally if I just change this collision data. Yeah, I could show that. It wouldn't even be that hard to change this. So basically this tile here, as I've shown before, it just has a height of 16. So all I'd have to do is just, if I change that to 0 and save it, and we go back onto that ladder, he'll be able to move through that tile now, and all of the input will be handled appropriately based on that. So yeah, he's moving side to side, can move diagonally, all that good stuff, which is handy because if I want to add a little climbing puzzle or something in the demo, it'd be pretty easy to do just based on having this implemented. So let's take that back out. Yeah, I don't know, I don't have much else to show in the actual game. We can go into some of the coding stuff if you really want to. There's nothing really that crazy. This is basically so the entry point of the application basically just instantiates a new demo game class and just runs it. So this is kind of the entry point of the game. This is just kind of some configuration that gets run, just setting up like the camera, the controller which controls the sprite. There's just some effects that it initializes but doesn't use, it uses the HQX one right now. Unless it's in debug mode, then it doesn't use any effects. As far as code-wise, a couple of the biggest or most important classes are this Sprite Controller class, which takes in all the input from the keyboard and relays it appropriately. The map class does all the drawing and updating, so everything just kind of gets routed through there. If I go down into here, this method just kind of makes all the event data, just reads it from that tiled map. This just creates all the collision data. Pretty boring stuff. This draw collision data is called when I'm doing debug mode and stuff. So that draws all those rectangles and triangles and circles. And in terms of drawing, what basically happens is it draws a 240 by 160 texture, which is the resolution of Game Boy Advance. And then in this class, it basically just scales it accordingly. So right here, it gets a texture that's 240 by 160, and then if I want to put an effect in, I can do that here, and then it basically just draws that texture stretched to whatever size I define, and then whatever effect I want, if it's nothing or a shader. So just as an example, I can change the window scale to 2 here, and it will just make a smaller screen or window. What else can I show you? So basically the map is drawn as layered data, and each tile is actually drawn individually, and it's given a depth that it's drawn at, which handles all the layering and stuff. So I can draw stuff in this sprite batch in any order I want, and when it actually draws it, it will sort everything and draw it in the correct order so that a tree doesn't get rendered over top of Isaac and stuff like that. This code is actually the thing that draws Isaac. It normalizes his depth and then draws him. If he is a collisionable object, then it will draw collision data for him. This little bit of code right here is drawing the smoke, which I can show you. It's doing an additive blend state, which if I open this, you'll see that it's just black with this gray cloud. So when you do an additive blend state, what it will actually do is take the pixel color data and then add it to the drawn data already. So since black has a pixel value essentially of 0, it doesn't add anything for black. But since the gray is non-zero, it will add those color components to the rendered result, which is why you don't see the black. You just see this thinly opaque smoke. What else can I show? Well, that's the map class, which is one of the big important classes. This is the Sprite Controller class. It does a lot of the logic. I'm happy with it right now. It's fairly clean. Basically, every cycle it does an update, and depending on what state he is, it will go get what method should handle him at his state. So if he is in the normal state, it will update based on him being in a normal state. If he's sliding, climbing, etc., which keeps it pretty segregated and clean. This fall height thing was a little bit interesting because in the game there's actually basically gravity, and they can, in the engine, you can drop a sprite from any height and it will apply gravity to them, and then at the end he will kind of bounce up. And it was actually kind of annoying because you have to apply that gravity principle when he jumps off the ladder and stuff, which was definitely a pain in the butt to get working properly. I spent a while trying to make those ladder timings as close and accurate as possible to the actual game. This get collision data method is pretty crucial as well. This is right now how this is basically just getting that green circle for the sprite, and then just uses his default radius, which right now is 8, but it could be anything else. I'm running out of things to show, but let's see. This is kind of where I keep all the collision configuration stuff. So at the root there's like a collision tile, and then if you remember I talked about circular tiles, triangle tiles, and just straight up rectangle tiles. So these are the 3 tiles that hold that data. If we go into the triangle one, for example, you'll see that that type property in the tiled editor is now corresponding to triangle, and then depending on how that orientation property is set, it will give me a triangle accordingly. And then this method, which is on all of the tiles, just tells me if one of those points on the green circle is intersecting with this triangle, and if it is, then I use that flag as basically to determine if a collision is going to happen, and all the glancing and stuff like that. Let's see. It's not a whole lot else to show. So right now I just unlocked the frame rate on this, and it's running at around 650 frames per second. Yeah, still lots of work to do, but I don't know, hopefully this random babbling gave you kind of an idea of just the structure and how I'm doing certain things. In terms of my next focus, I'll either probably make that move synergy so you can move the snowman that's supposed to be here onto the ice, or I'll do just all of the little shops and stuff so you can go into each building. I haven't really decided yet, but it takes a while to do some of that stuff because you kind of have to figure out how it goes into code and where it fits architecturally. But yeah, hopefully this video helped out a bit and you got to see some of the stuff you wanted to see. If not, just let me know. Yeah, I should probably at this point kind of tell you that you should subscribe and follow my Twitter and all that stuff. YouTube subscribers it's definitely the thing that motivates me to keep making videos. That 6-month hiatus, definitely felt guilty seeing, you know, a couple hundred people had subscribed to me and they hadn't seen a video in 6 months. They didn't know if I was dead or alive, and that's my fault. But yeah, definitely subscribe if you haven't. Keeps me motivated and you get to know when I post new videos. So yeah, thanks for watching. Hopefully next video will just be I don't know, entering into buildings, which I know you guys have seen before, but since I have to recreate it all, I'll just keep adding those videos so that you know I'm not dead. Yeah, thanks for watching.